Hi everyone, this is our October 2018 Haskell feedback video. Well done, there are more than 1,000 learners on our Haskell MOOC. It's great to see the way that you're all interacting with each other, asking questions in the comment sections and answering each other's questions as well. Also, we're really delighted to see the way you're engaging with the different exercises, and particularly the peer assessment exercise. I know there have been some problems with this. Sorry, it's to do with cross-site cookies, apparently, but hopefully there should be a setting on your browser that you can alter so that cross-site cookies are allowed, and then you'll be able to submit your exercise for the peer assessment spelling book generator application. Do let us know if you've got any more problems with that. We're moving into the review phase for that this week, so you'll be able to look at other people's submissions and maybe assess them in the light of the work that you did. I just want to focus on one particular topic that we've covered in the last week and maybe just try and shed some more light on it, because there was a bit of confusion about data constructors and type constructors. So remember, this is the tree data type here that we looked at. We've got data tree A, let's say, equals a leaf, or it could be a node which stores an A and also has two subtrees which are A's as well. Okay, so what I want to do is point out here what is the type constructor. Tree A is the type constructor. And what are the data constructors? They are leaf and node. Okay, so the type constructor allows us to construct types. Tree is the type constructor. A is the polymorphic type variable, so you can make trees of ints with the tree type constructor, or trees of lists of ints, or trees of trees, or trees of booleans, or any type can go there in the alpha for the polymorphic whole type variable. So tree is the type constructor, and these things here are the data constructors, because these are things that allow us to make values of the type of tree. You can consider node, for instance, to be effectively a function. Okay, and this is going to take something of type A and something of type tree A and something else of type tree A. They're the parameters to the constructor, and it's going to return something of type tree A, which is the node itself. So node is a kind of constructor, a data constructor, because when you give it the right arguments, it'll give you back a value of type tree A. Leaf is also a data constructor, but it doesn't take any arguments because there's nothing inside the leaf. It's a kind of base case, if you like. So leaf 2 is a data constructor. Right, we can talk more about this in the comments if you want to, but I hope that makes things a little bit more clear. Perhaps the discussion was slightly confusing when we covered this in week 3 of the course. Just one more thing to say before I go. The material is going to become significantly more complex in week 4 when we look at parsing, and also in week 5 when we look at more complex constructs like monads. Do stick with the course though. We're going to support you as much as we can and carry on talking in the comments section, asking questions and trying to learn more about this really exciting functional programming language, Haskell.